Good afternoon, everyone. My name is Sharma. I'm Associate Professor in Department of Computer Science at Bowie State University. I'm also the Director of Virtual Reality Lab. So today I'll be talking about the megacity project. It's a collaborative virtual reality environment for emergency response, training, and decision making. Let's see if that works. Yeah. So determining and evaluating characteristics of a crowd is a very tedious process. And generally, surveys are done by asking people where they're going and why they choose to stay at a particular point. Also, it's not practically possible to create a real-time emergency and with fire and smoke and ask people to evacuate, right? It's possibly because of legal and health issues obviously involved in it. Again, the cost and risk to determine these crowd characteristics, which are very important, is very high. So Pushparev in his research, he made an aerial count of New York train station. This is a typical example of a jammed flow, people coming out at the same time from the New York train station. So he made an aerial count over here, 37,500 people coming out at the same time. So if you were to do an evacuation drill and try to find out the characteristics of a crowd and how people are going to behave in case of emergency, not possible, right? But the way that we are proposing or what we are saying is doing that in the virtual reality environment. As long as you can collaborate inside the virtual environment, you, me, all of us together, we are present in the virtual environment and we can look around and see as an immersive environment around 360 degrees, right? So if you feel like you are immersed in the environment, you are more likely to gather real-time data. With the technology recently, I would say last 3-4 years have been greatly improving, especially with the Oculus Rift and HTC Vive coming into picture. You get a more immersive feel of the environment. So the more you feel the environment is real, the more you feel that you are part of that environment, the more the chances you'll gather more real-time data of how people are going to behave in emergencies. Because when emergencies do happen, you won't be able to gather the real-time data. If you knew it beforehand, you'll rather stop that emergency from happening, right? So one way is to overcome this issue is to create this virtual collaborative environment that can give a full immersive feel of the situation. So out here, the big question this research seeks to model is a collaborative virtual environment that includes human behavioral modeling for emergency response, training, and decision-making strategies. So modeling human behavior, that's what I've been doing for more than a decade. That's where the heart of the research lies. It's very difficult to model because of obviously the uncertainty involved. If we were to do evacuation drill right now in this place, fortunately there is no exit over there, but if there is an exit and if I'm trying to exit out, I will not always look for the shortest possible path. If an exit is not visible to me, but it's close to me, there's no way I'll go towards that exit. Because we human beings, we have memory and we have those things associated with us. So a robot will always look for the shortest possible path and look for the shortest exit and evacuate, right, in case of emergencies. But we as human beings, we have memory in place. So say, for example, if you go to a movie theater and if there is some emergency, the most likely way would be you'll retrace your way back the way you came in. But while on the way, if you learn from other people what they are doing, and if they are going through another exit, that will add to your list, almost like a linked list, right? Me being from computer science. So it will add on to your list of goals or list of favorite goals. And then based on that list, you'll make a decision of what you know and what's the best available scenario for you to evacuate, right? So our proposed collaborative virtual environment of this megacity environment, it offers the flexibility to run multiple scenarios and evacuation drills for disaster preparedness and response. So modeling such an environment is very important because in real-time emergencies that we experience in day-to-day life, there's a need to prepare for these emergencies. And there's a lot we can learn from pre-existing, the disasters that have happened before. You could actually recreate those in a virtual environment and see what were the shortcomings and how we can learn for the future, right? So we do a lot of evacuation drills. We have done airplane evacuation drill. Of course, being in campus, we do campus evacuation drills. So doing virtual evacuation drills with smoke and fire, with real-time objects and real-time environment gives a more lively feel, and the users of the environment, they feel as if they are part of that environment. It's more likely to gather more important data about human behavior. So again, virtual evacuation drills, regardless of even if it's a campus, evacuation, subway, or a city, is very important. And especially because human behavior is involved in it, and people in emergencies, their behavior becomes unpredictable sometimes. And especially because of panic and stress, it becomes even more unpredictable. So there have been a lot of studies done for panic behavior. We ourselves, we have tried to include fuzzy logic to model human behavior, especially the panic and anger aspect of it, to see how it affects the speed of the person when they go towards the goal. So the use of collaborative virtual environment allows us to run virtual evacuation drills. It eliminates the risk of injury to participants. It allows for testing of scenarios that cannot be tested in real life due to legal and possibly health issues. So what we have been working on is a megacity project. It's a busy city, and we are trying to model a few emergencies. We are looking into fire, smoke, gunman threat, or a bomb blast, or it could be a bio threat also. So the collaborative virtual environment kind of acts as a platform for training and decision-making strategies. So the SWAT team could be collaborating with their commander on the back and strategizing how to take care of the busy intersection where, say, the fire is there or the terrorist attack or something is happening at that intersection. Maybe it could be fire. So how to strategize and take care of the situation. Same thing goes with the fire respondents, and same thing with the traffic clearance staff. In a busy intersection in a city, if there is an emergency, there will be a lot of traffic that will form up, and it's important to take care of that. And especially this environment kind of provides you that training background of looking into strategies of how you do that and follow the proper procedures. And of course, the medics, how to take care of the injured people who are there at that place. So we have used game creation as a metaphor for creating this experimental setup to study this human behavior in a megacity for emergency response, for decision-making strategies, and for different what-if scenarios that you could create. So our proposed environment could be used as an immersive environment. If you are wearing Oculus Rift, you could be entering as an avatar, and you'll be having autonomous control of your avatar, and you can move around wherever you would like to be. And second is using a non-immersive environment, that is using the computer and keyboard to navigate your avatar around. It's almost like playing a video game, right? So, and the network, basically the whole setup is actually based is over the cloud. So you are entering the environment as an avatar, and the environment is over the cloud. So there will be no problem with the LAN and wireless issues. I could be probably entering the environment from my house, and somebody else could be entering from here, but we are all present in the same environment at the same time with different avatars. So our hypothesis is that the sense of presence that is provided by the virtual reality environment will allow conducting these evacuation drills for emergency response. And of course, these drills are more cost effective, they take less setup time, and they're able to simulate real dangers, and they have improved response time too. Our methodology is based on the experimental design approach for assessing human behavior under extreme conditions. That does involve a lot of issues like trust. How do you trust the other person? Maybe if he's wearing a uniform, you're more likely to trust that person as compared to a random person. So, and you could look into stress, panic, and anger. So those are the things that we are looking into. It's basically participant observation and data capture in the experimental setup. So in this environment, we kind of have two types of agents. One are the user-controlled agents. That means the users who are acting as avatars, they enter the environment, they pick up their agent, their avatar, and they can move around autonomously. Then there are computer-controlled agents in the environment, which I'll talk about in the next slides, which you can create as red agents, green agents, and so on, applying different behavioral characteristics on top of it. So you can choose before starting the simulation how many of those you want in the environment, and then you can enter the environment as autonomous agents. So these are a couple of screenshots of the environment that we are looking into. You would see these people kind of look like red and blue agents. So we are knowingly putting them as red and blue agents for the time being. We can obviously replace them with other agents. But it's more about the behaviors that we are trying to implement on top of those agents. So out here, you could probably see there's a fire over there, and there's a police officer, a patient lying on the ground, and the emergency vehicles and police cars are there at that intersection. So looking into terms for agent behavior, we are looking into hostile behavior, which are red agents in our case. We are looking into green agents, which are non-hostile agents. We are also looking into leader-following behavior, which are blue agents, goal-following behavior, selfish agents, and we are also implementing panic behavior inside the agents. So panic behavior kind of depends upon how far you are with respect to the emergency, and if you are in high stress and panic, and if you are very far, you're likely, your speed will increase and decrease based on that analogy. So these are a couple of behaviors that we are looking into. So again, with regard to the implementation, the model or the environment was developed in Unity. Before it came into Unity, we modeled it using SketchUp and 3ds Max. We involved all the 3D models. The programming was probably done in C#. We added more algorithms for traffic light, green light, red light, and all those issues inside it. Then we added the behavioral modeling, added algorithms for the agents, as well as we added the Photon Unity. We used the Photon Unity networking to implement the cloud setup and the client-server interaction. The agents can chat with each other and interact with each other. So again, this is another screenshot of the environment, and you could be entering as a policeman over there, and if you are close to the blue agents will follow you. We tested our approach using 10 clients over here. The 5 user control agents, they acted as police officers, so they were in charge of collaborating with the commander and taking care of the busy intersection. The environment, as I showed, it does incorporate smoke and fire, and the users are able to use Oculus Rift to immerse themselves inside the environment. So again, we modeled the bomb threat, we modeled the gunman threat, and the biohazard threat for the time being. We are still working on this project. So this particular one shows the bomb threat scenario where the explosion is triggered and the police vehicle and fire trucks are there inside the environment. So out here, the users are able to wear the Oculus Rift and immerse themselves inside the environment and look around from the agent's perspective and move around autonomously. The motion sensor direction on Oculus Rift allows for tracking the user head movement. This leads to the user to visualize the megacity environment and other agents who are present in the environment. They can also use the chat functionality if they wish to. Again, stress and panic and anger could be induced through the use of smoke and fire. And again, it's not possible to do that in real time, but in virtual environment, you could do that. And if the environment feels real, you're more likely to get more real-time data of how people are going to behave in case of emergencies. So a couple of things. In conclusion, we presented an experimental design approach to gather the data on human behavior and emergency response in a megacity environment using a group of agents. Again, it's user control agents and AI agents that are programmable agents. Collaborative virtual drills can also help us to see how long it takes for the emergency responders to report to a certain location and respond to the emergency situation. The data collected can be used to educate emergency personnel on how to reduce response time. And of course, emergency personnel can be trained to respond to a variety of scenarios and what-if situations depending upon where the threat is and where they are located. So you can create all these what-if scenarios before you start the simulation, and you can decide how many hostile agents, non-hostile agents, how many user control agents you have to act as policemen or to act as medic or to act as patients over there. So it's a platform for strategizing, for training, for education, as well as for safety purposes, and without being exposed to real dangers, you could look into how to strategize your way out. A couple of references, and I also wanted to acknowledge the Army Research Lab for their funding, as well as NSF and Thurgood Marshall College funds. That's very much it, what I wanted to cover.